How do you click? What do you need to do? I hate
know
this.
this. I hate this.
Are you huh? Are you gonna use this? Oh, yeah. Wait, get to the gift. Yeah. And it'll eventually, it'll eventually happen. And then open a browser. Restart. When you open the browser, keep
You're going to need one of these. Okay, so if you would, hate to say come grab, but maybe I can just, I'll go pass one around. Pass one around up here. Did everybody get one of those handouts? If somebody comes in, would you just kind of make sure they get one? Thank you. Okay, guys, I want to mention something about Blackboard compared to My Math Lab. When you work in My Math Lab, Blackboard pulls from what you do there and dumps your grades into Blackboard. Another thing that I became aware of today as a student called and showed me a discrepancy is that in My Math Lab, let's say I say that your due date is tonight at 11:59. Blackboard is saying that the due date is actually tomorrow. I think it's rounding, like because you're so close to midnight, it rounds it to the next day. And so, no, so we've got a problem there. So I'm going to say always look in My Math Lab. When you click assignments, it says there beside the assignments when it's due. That's the appropriate time. If before today you thought the assignment was due tomorrow, you know, like if you had a midnight crisis where you thought it was tomorrow, but it was actually today, email me and I can adjust that. But from like this moment on, the priority is you look in My Math Lab, and beside that assignment, under assignments, it tells you the exact day and time. That I've been playing with it, and I'm trying to get them to line up. So far, I've changed the due date time to 2 o'clock, and it's kept it on the same day. But even at 11 o'clock, it throws it to the next day. So unless I shorten your time, then it's going to bounce it to the next day. So for right now, you always look in My Math Lab to know the exact due date and due time. Okay? All right. If you have any questions, email me, call me, okay, and I'll get that straight with you. I've had a couple of questions about some of the homework, and so I want to go over a few of those problems real quick at the beginning of class before we hit the worksheet that I passed around. The first problem that someone asked me about came from R4, and this particular problem asked us to factor, and they said to use substitution. And this is definitely one, if I looked at it, where I would use substitution, because what is being squared isn't very simple. It's not just one variable. And remember, when we use substitution, most of the time we'll use the letter U. So what we're doing here is we're letting U represent 2r minus 1. Then that looks much more doable, less intimidating. And then you're going to need to just factor that. And just for time, all right, I'm going to tell you that I factored this. And when I factored it, I got U plus 3 times 7U minus 5. Okay? So remember, I rewrote the middle term as 2 terms, did grouping, factored out what I could. This would be my answer, except it has U's, and my original problem had X's. So I have to go back, and in the place of every U, I have to put in 2r minus 1. And they do expect me to continue simplifying and cleaning up. Now, the first parentheses here aren't necessary. They're just grouping it, and there's addition beside it. I don't have to leave that there. So this is really 2r minus 1 plus 3. In the second one, I do need to distribute 14r minus 7. Combine like terms. (14r minus 12). You're still not finished. Always when you think you're finished, ask yourself, can I factor anything out? Is there a common factor in each of those groupings? And there's a 2 in the first one. And there's a 2 in the second one. So the actual answer is 4 times r plus 1 times 7r minus 6. So I'm thinking if you were able to do the substitution in the beginning, it may have just been that you didn't keep going and keep taking out whatever you could. Okay. So if you still are not sure about that one, let me know. I can make a quick little video, or I can just talk to you individually, okay, if there's something you still aren't sure about that problem. Any questions right now about that problem? Okay. The next question that someone asked me about came from section 1.4. And it was 2x squared plus 11x minus 1, and they specifically wanted us to complete the square. And I know the ugliness of this is we have to deal with fractions. Remember, the first thing is we want that coefficient of x squared to be 1. So we're going to divide every single term by 2 to make that first coefficient a 1. Then we take that third term, move it to the other side. Then we take what was the middle term. Remember, we take that term, we take half of it and square it. This is going to give us a perfect square. So we're starting with 11 halves. We're going to take half of it and square it. So that's going to give me 11 over 4. I want to square it. 121 over 16. So if I did this correctly, I should have a perfect square on the left-hand side. And remember, the number that's going to go next is the number that I squared, which was 11/4. And then you're adding 1/2 and 121/16. That gives me 129/16. Now I have one term squared equal another number. So I take the square root of both sides. So I would be able to write that as the square root of 129 over 4, because the square root of 16 is 4. And then you just subtract 11/4 from both sides. So there are two answers there. Negative 11/4 plus square root of 129 over 4, and negative 11/4 minus the square root of 129 over 4. Any questions about that one? Okay. The other two questions that I had came from 1.2 homework. They were the last two problems in that section. They were about interest. And these are the two that I didn't take time in class that particular day to make the chart for you. So now maybe is a good time for me to look at that. Interest is equal to principal times rate times time. Principal is the money that they put in that they want to generate income off of. Rate, they're going to tell you the rate. And time is usually annually. If it's other than that, they'll have to tell you if it was months or more than 1 year. But usually it's annually. The chart that you're going to make, they usually are just comparing two. They could compare 3. But usually they're comparing 2 lump amounts of money that they put in. So we'll just call this amount 1, amount 2. And we'll have our principal, our rate, our time. And if I multiply those together, that will equal my interest, the amount of money that I earn. So the particular one that they were asking me about was number 16. And for number 16, they already had the little chart worked out for you and filled almost everything in but the last column. Okay, so what was going on in number 16 is they were going to put a certain amount in at 9% and a certain amount in at 7%. But they didn't tell you how much they were going to put in each individual account. So you just had to go ahead and say, I'm going to let X be the amount of money I put in at 9%. They did tell you the total amount of money they were going to put in. And in that particular problem, they were going to put in $175,000. So here you would have 175,000 minus X. That would be the other part. Make sure when you plug in your rate that you move the decimal 2 places to the left. So I have 7% and 9%. And this was annually. So what's going to go in this interest block is just 0.09 times X and times 1, but I don't have to write times 1, and 0.07 times 175,000 minus X. So I think that might be the column that they didn't fill out for you. Okay. So you needed to know principal times rate times time equals your interest. And then in this particular problem, they told you what the total interest was, how much they were going to earn. And they wanted to earn $14,150. So this is what your equation should have looked like for that problem. And then you would just solve that problem for X. And you would get $95,000. So they would put $95,000 in at 9%. And then you just subtract that from 175,000. And you would get 8,000, and so they would put $8,000 at 7%, and this was at 9%. Okay. So I think with number 16 and number 17, the key there was knowing the little chart and where to put in all your little parts. So take this and now go back and try to do 16 and 17 using that kind of chart, all right? And see if you have any questions about what you're doing there. And I can make a video too if you just shoot me an email. The only difference is in number 17, they tell you, I'm going to put an amount in at 1.5%, and I'm going to put twice that amount in at 2.5%. So I'm going to use X and 2X. So do try that and let me know if you have trouble with any of that. Does anybody have questions about anything else? All right.
Ma'am? There were some questions about purity, like mixing two substances together. Can you explain how to do those?
All right. Do you know, okay, when you do that, there are 3 basic types of problems. There's one that's going to have, you're mixing 2 mixtures together. One is 30%, one is 70%, and you want to end up with one that's 40%. Then there's mixtures, and this may be what you're asking me because you use the word purity. Maybe it's a problem where they're going to mix water, which would have 0% of anything else, or they're going to mix pure alcohol. Is that the type of problem you're speaking of?
No, it was the first one you were speaking of.
The first one. Okay. Do you know what particular problem that was?
No, ma'am.
Okay. What I can do, since I don't know exactly which one it was, I'm going to set back up the chart that you would use, okay? Okay, this is the chart that you're going to use to fill in when you do that type of problem. Let's see if I can pull up one real quick. And just for next time, it's really helpful if you can say, okay, I was working in 1.2 and it was similar to problem 4. That way I could pull that problem up in my math lab and we could all look at it instead of me trying to make one up. This is an example that I did the other day. With this particular one, it says how many gallons, so this would be in your notes from the other day, how many gallons of a 50% antifreeze solution must be mixed with 100 gallons of 10% to get a mixture that's 40%. So again, the type of problem I think you're asking me about is they're going to give me 3 different percents. I'm going to be mixing 2 of them together, and I want an ultimate one at the end, the mixture. So shorthand notes would be how many gallons of 50% antifreeze solution must be mixed with 100 gallons of 10% antifreeze solution to get a mixture that's 40% antifreeze. So you see how we're mixing a 10% and a 50%. We want to end up with 40%. And they said, how many gallons of 50? So I'm going to let the first one represent 50, the second one represent 10, and the last one represent the 40. So label them on the left-hand side so you'll know who goes with what. So how much of the 50 goes with 100 gallons of the 10? And I want to end up with 40. So to the young man, and I'm sorry I don't know where you are in my virtual world out there. Can you wave at me? Maybe I can see you. Where are you? Yay, I see your arm. See your arm. Yay, thank you. Okay, first of all, do you understand where I've put everything and why I did that?
Yes.
Awesome. Okay, so now the total amount of solution is going to be X plus 100. Okay, because I had X amount for solution 1 and 100 gallons of solution 2. Then going across, if I want to know how much antifreeze do I have, the first row would have 0.50 times X. The second would have 0.10 times 100. And the last one would have 0.40 times X plus 100. Okay, are you okay with the way I filled in the last column?
Yes, ma'am.
Okay, and the last step we're going to do is if I take the amount of antifreeze in solution 1 and add that to the amount of antifreeze in solution 2, that should equal the amount in my mixture. So that's what I use to write my equation. So I will have 0.50x plus 0.10 times 100 equals 0.40 times x plus 100. And you would just solve that for x, and you get 300 gallons. Is that the type of question you were concerned about?
Yes, ma'am.
Okay, does that help you?
Yes, ma'am.
Okay, and if you, as you work through these, if you're still not sure about another one, shoot me an email, okay?
Yes, ma'am.
Any other questions? Okay, we're going to look at the worksheet that I've passed out, and hopefully was everybody else able to get a worksheet, a handout? Yes, yes, yes. This is just so that you don't have to write down everything. All right, number 1 on our handout says, find 2 consecutive even integers whose product is 168. So the point to this particular problem is making sure you know how to represent even integers compared to odd integers and just consecutive integers, right? So find 2 consecutive even integers. So I need to let x be my first even integer. Okay? And I doubt this is all going to fit in that little space. Okay, so be careful. You'll never squish it all in. So you'll probably want other paper. So if x is my first even integer, how do I get to the next even integer? Add 2. All right, I want 2 consecutive even integers whose product is 168. Product means multiply. So notice that once I use my distributive property, I have a quadratic, which is what we just got finished doing in the last class. And in your homework, you have a quadratic. To solve a quadratic, you get it set equal to 0. And then you get to choose. You can use, when they don't tell you, you can choose any of those methods that we talked about last time. You can use any of those. So the quadratic formula always works. But when my coefficient is 1 in front of my x squared, I usually try to factor it because if it is factorable, it shouldn't be that hard to do. And this does factor. Again, you could still use the quadratic formula. But when I factor this, I'm dealing with negative 168. So I need it to multiply to be negative 168 and add to be a positive 2. And that's a negative 12 and a positive 14. So at this point, I use the 0 factor property where I set each factor equal to 0. So I have 2 choices. I have a 12 and a negative 14. In the beginning, they did not say that x had to be positive. So x could be negative, that's fine. So if x is 12, then to find the next one, I add 2. That would give me 14. And if x is negative 14, I add 2, and that gives me negative 12. So I actually have the grouping of 12 and 14, and negative 14 and negative 12. So I have 2 options there. Okay, any questions about that? So really that one's to make sure you understood how to represent even integers, consecutive even integers. With number 2, they say the difference of the squares of 2 positive consecutive odd integers is 32. So I need to make sure I can represent positive consecutive odd. So just start with letting x be the first. So how do I get to the next consecutive odd? If my first one is the number 3, how do I get to the next consecutive odd? What do I add? I still add 2. So if the first one is odd, to get to the next odd, I still add 2. If the first one is even, to get to the next even, I still add 2. So it all depends on how you define that first variable. Okay? So x plus 2 is your next positive odd. So it says the difference of, so what am I going to be doing when it uses the word difference? Subtracting. And I'm going to subtract the squares. So I want to square each of those. Now, it says that my answer, the difference of the squares of the 2 positive consecutive odd integers is 32. Notice 32 is a positive number. If you're subtracting 2 numbers and you're getting a positive answer, that meant you had the biggest one first and subtracted the second one from that. So which one is larger, x or x plus 2? X plus 2. So x plus 2 squared minus x squared equals 32. So you have to make sure you write the larger one first, subtract the smaller one from it so that you'll get a positive 32. If you wrote it down opposite, you would end up with a negative 32. Okay, I'm going to give you a minute. Work that problem. Make sure with the first part that you FOIL it out, then subtract x squared from it, get your quadratic set equal to 0, and solve. So if you FOILed correctly in the beginning, they were nice to you. They actually eliminated the fact that you had a quadratic here because your x squares canceled out. And once you find out that x is equal to 7, then you need to make sure that you find the corresponding other value that you needed, which was x plus 2, which is 9. So the 2 positive odd integers are 7 and 9. Okay. Any questions about number 1 or number 2? All right, number 3. The lengths of the sides of a right triangle are consecutive even integers. It doesn't matter who you start with to call x, but I'm going to make sure that I have x, and they said consecutive even, so x plus 2, x plus 4. But what you should remember is that in a right triangle, you should be thinking, oh, a squared plus b squared equals c squared, the Pythagorean theorem. And you should also be thinking the hypotenuse is always the longest side. So when I did choose x, x plus 2, and x plus 4, you would want to make sure that x plus 4 represented your hypotenuse. All right? And so, just like I said, we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, right? So x squared plus x plus 2 squared equals x plus 4 squared. So with these, it's really the setting up that you want to be careful with. After that, you're just number crunching, okay? Doing algebra that you've done for several years. Okay? So FOIL out x plus 2. FOIL the other side. You have x squares everywhere. You know this is a quadratic. You want to get it set equal to 0. So we're just going to move everything to the left-hand side, combine like terms. When you do all that, you're going to have x squared minus 4x minus 12 equals 0. Okay, that's moving x squared plus 8x plus 16 to the other side. You just factor. Before I go on in this problem, does anybody have any questions about any step that's there? You combine like terms, move everything to one side so that's all set equal to 0. It's a quadratic. You factor it, use the zero factor property, set each one equal to 0. And I have two choices. X is negative 2 or X is 6. But remember, in the beginning, this is the length of the side of a triangle. So length is never going to be negative. So I can't have a negative 2, okay, because the length of a side cannot be negative. So x can be equal to 6. And then remember I had an x plus 2 and an x plus 4. So your lengths of your sides, and they didn't tell us if it was inches or feet, so we don't have units to put down because they didn't tell it to us. So the lengths of the sides would be 6, 8, and 10. So I would call these maybe warm-ups, because now when you're getting to the next one, you see this problem commonly in college algebra or this course that you're in right now, pre-calculus algebra, common. And especially as we work on through to number 7. You see number 7 that goes right on through to not only pre-calculus, but calculus. Okay? So it's basis for those things. Okay, so for number 4, we're going to read carefully number 4. Zach wants to buy a rug for a room that is 12 foot wide by 15 feet long. He wants to leave a uniform strip of floor around the rug. He can afford to buy 108 square foot of carpeting. What dimensions should the rug have? As usual, whenever you can, sketch you a little picture. All right, so we're going to draw our rectangle of a room. And the room is 12 feet wide by 15 feet long. He's going to put a rug inside. And he wants to leave a uniform strip. So that means all the way around, this distance from the rug to the wall is going to be X. Because it didn't tell us how wide a strip he wanted. He can afford to buy 108 square feet. So we know that up in here we've got 100, 108. Square feet of rug. So if I knew the dimensions of the rug, I know length times width should equal 108, right? Because that's the area that they told me. So I need to use the dimensions of the room and the fact that I have that border to determine the length and width of my rug, right? So let's look at the length of my room. The length of my room is 15. The length of my rug
Is it going to be
15. It was shrunk in by X on each side. So this is 15 minus what? Very good, 2x, not just x, but 2x. So a common mistake is that someone would write 15 minus x instead of 15 minus 2x. And then my width of my rug would be what? 12 minus 2x. Right, you know, area is equal to length times width, and our area was 108. This is for my rug. 15 minus 2x times 12 minus 2x. So once you've set it up, you're back to doing homework like you did hopefully last night, right, from what we talked about before. So then you're foiling that out. It's a quadratic. I know many of you haven't done your homework yet. You're going to multiply that out. It's a quadratic. Get it set equal to 0. Factor, right? So this is what we'll get. Because it's a quadratic, we're going to set it equal to 0. I'll give you a minute to get all those numbers written down. Now, when I'm factoring, just because I like it in order, I would rewrite this so that my x squared is first, but just make sure if you go moving things around, you keep the correct signs with everybody. Just because I'm used to factoring when my x squared is first. Also, if I can make my numbers smaller, I do that. So I have a 4, a 54, and a 72. They're all divisible by 2. So I'm going to divide by 2 on both sides. 0 divided by 2 is still 0, just to make my numbers smaller and easier to work with. This does factor. And you get 2 choices for x. Now both of those are positive. So it looks like maybe they could both work. Does anybody know which one wouldn't work and why? Anybody willing to say? The 12 won't work. It's too big, right? Think about the sides of your room. The width of your room is 12. You can't subtract 12 from it because you're going to not have any room left, right? So 12 is just too big. So our only choice is 3/2 for the width around the rug. And the question was, what dimensions should the rug have? So be careful, you found X, but you haven't answered their question yet. So you need to make sure that you answer their question. The length of the rug, and remember the length of the rug was 15 minus 2x. So the dimensions would be 12 by 9 feet. Okay. With the next one, I'm just going to set it up for us. This is also a common one that you see in this course. It says a rectangular piece of metal. So draw your rectangle. A rectangular piece of metal is 10 inches longer than it is wide. So I'm going to let x be its width. So the length is going to have to be x plus 10. Squares with sides 2 inches long are cut from the corners. So they come to each corner and they cut out this 2 by 2 square. The flaps are folded upward to form a box. And I usually have one already done. So I'm going to real quick because I can be visual. And it's helpful sometimes to see a picture. All right. So real quick. So it's like this is my piece of metal, and they went and they cut out a 2-inch square at each corner, and that allows them to fold it up. You see that? So that creates this little box. So that's what they've done. They cut out this 2-inch square in each corner, and that lets them fold it up. And it creates this box. I don't know how good y'all can see that on the TV, but so we create a box. It's flat. They cut out their corner, and that makes them be able to make a box. Okay? And boxes have volume. So that's why they start talking about volume next. The volume of the box. So volume is 832 cubic inches. What were the original dimensions of the piece of metal? Do you remember how to find volume? Right, length times width times height. But it's the volume of the box, not the length of the original piece of paper or a piece of metal. It's got to be the length of the box. Look what I did to my length. I'm actually going to, it's going to lose 2 inches, right? But it's going to lose 2 inches twice, right? It's going to lose 2 inches twice. So just like on the rug that we had before, we had to come in on both sides. With this, you're going to have to lose 2 inches on the left, 2 inches on the right, 2 inches on the top, 2 inches on the bottom. So for my box, I need length times width times height. And don't let my x's look. Okay, that's going to be my volume. Volume is length times width times height. Oh, they can't see me. Thank you.
Can you see it now?
She just zoomed in.
No. You can't see the computer? See her.
Can't see the computer.
We see it in Columbia.
We can.
I'll do it the old-fashioned way. Go ahead.
Okay. All right. Okay, so for the volume of the box, we're going to have length times width times height. All right, so the length of the box is only going to be this red part. It's not x plus 10. What is it going to be? Yes, x plus 6, because the length of my box is going to be x plus 10 minus 4, because I lost 2 inches and 2 inches. The width of my box is going to be, used to be x, but now it's what? X take away 4. And what's the height? 2. So where it says up here, x is the width, this is of the metal. That's the metal sheet. Okay, so x was the width of my metal sheet, and x plus 10 is the length of my metal sheet. But x plus 6 is the box, and x minus 4 is the box. So you have to keep the relationship going, right? And then all you have to do after that point, see, the hard part is setting it up. You're going to multiply that out. It's going to be a quadratic. You're going to get set equal to 0, and you're going to solve for x. But you can't factor. I will tell you, as you go through to solve this, you have to use the quadratic formula. And the answer is going to be well, I suppose you could have factored, but it wasn't very easy. And this was some negative number. So our choice here was an x that's equal to 20. This is why I was saying it's important that you know what x represented in the beginning, because if you think this is your answer, you could be wrong. It says, what were the original dimensions of the piece of metal? You do get that x is 20, and x does represent the original piece, but you haven't finished because you have to give length and width, right? So remember, x plus 10, 30, okay? All right, what we're going to do is we have 6 and 7, so I'm going to start with number 6 and number 7 next time, but the homework is already open, and you can go ahead and do almost all of it, okay? Do that. And watch out for my math lab, making sure you pay attention to due dates. Okay? All right, see you next time.
We might get enough for next time, right? Maybe not next time.